Hello students, welcome back to the chemistry classes. Okay, so before starting our classes, let me tell you one thing. I'm very much happy to know that you all have passed out your 10th standard with a very good results. Congratulations to each and everyone. Okay, so do you remember all the things that we have discussed before? You got a very short vacation, right? So we were discussing about the first chapter. We have discussed certain topics also. Okay. And one thing happened here is that CBSE has revised their syllabus. Many of you might have known about it. So they have revised their syllabus. So some topics are removed from the syllabus for this current academic year. So unfortunately, all the topics that we have discussed so far till the law of chemical combination is removed, but still you have to study that because it will be there for your entrance test and all. It will be needed for your entrance exam, so you must study that. Then again today we will be starting with a new topic in the same chapter itself. The new topic that is about the atomic masses and molecular masses, and also about the mole concept. Both the topics you have already studied in your 9th standard. I know that many of you remember it. Some of you may not be remembering it. So anyway, we will be just revising all those topics one more time. Then I will give you some numericals also to solve it. Again, if you are having any type of doubts, you must contact me, clear it. I know that you were doing it very nicely in the previous classes. Now also you have to repeat the same thing. Any doubts, you must contact me, clear it. Okay, so we can watch today's video.
So dear students, today we are going to study about the atomic and molecular masses. So this topic you have already studied in your 9th standard, but still no, we are just going to revise it. Okay. So atomic and molecular masses, you know that atoms are very tiny. We can't even see through our naked eyes. So the atomic masses, so the mass of that particular atom means it will be very small. So the mass of an atom we call it as the atomic mass, and the mass of a molecule we call it as the molecular masses. So today we are going to find out how we can find out the atomic and the molecular masses. But keep in your mind that the mass of an atom or even a molecule, it will be very small. It will be very small. We know the mass of certain elements, right? So we know the mass of the hydrogen. Mass of the hydrogen is 1.67 into 10 raised to minus 24 gram. Right? We know the mass of oxygen atom. What is the mass of oxygen atom? It is actually 26.56 into 10 raised to minus 24 gram. So this is exactly the atomic mass of the oxygen also. But the problem is that here I have marked the mass of the atom in terms of gram. In terms of gram. Here I have marked the mass of the atoms in terms of gram. But you can see that when you here it is 10 raised to minus 24. That means its atomic mass is really very small, right? So how we are finding out the atomic masses of these elements? Nowadays we have very powerful techniques like mass spectroscopy, and every mass spectroscopy is a technique by which we can find out the masses of very tiny objects. But in the earlier times, mass spectroscopy, such type of techniques were not developed. At that time, what the scientists has done is that they have taken the relative atomic mass. They have done the relative atomic mass. What they have done is that they have related the mass of the atom, that which we are going to find out, with another atom. That is what we call as a relative atomic mass. They are relating. So one atom's mass, we are relating it with the other atom's mass. Okay, that is why we are calling it as a relative atomic mass. So scientists have started to find out which atom will be taken as the standard one, such that we can relate it. In the earlier times, we have taken hydrogen, as the hydrogen is the lightest element, the smallest one. So we have taken hydrogen as the standard one, but lot of difficulties were the mass that we are calculating is not becoming constant, or it is not becoming correct. So we have removed the hydrogen, then we have tried out with the oxygen atom, but again that also became wrong. After some time, they have tried with the lot of elements. After long time, we have found out that if we are using carbon 12 atom, as the standard one, we can find out the atomic masses of the other elements. So now we are using the carbon 12 atom as the standard one. Okay, what is the mass of the carbon 12 atom? Is we are connecting the carbon 12 atom mass as 12 AMU. 12 AMU. Here I have marked the unit as AMU. What is AMU? Atomic mass unit. Okay, atomic mass unit. So carbon 12's mass is 12 AMU. It contains 6 protons and 6 neutrons. So we have calculated the mass of the carbon 12 as the 12 AMU. So using this mass as the standard one, we are finding out the mass of the other elements, other atoms. So what we can define for the relative atomic mass? How can you define the relative atomic mass now? We can say that relative atomic mass is the mass of an element, compared or related with the carbon 12 atom. So that is what we can say about the relative atomic mass. So mass of an element, relative atomic mass of a particular atom is the mass of that particular element compared or related with the carbon 12 atom. That is what we call it as the relative atomic mass. So we have discussed that relative atomic mass is equal to mass of an element related or compared with the carbon 12 atom. Okay, so we are comparing the mass of an element with that of the carbon 12 atom. But here a problem is that we have taken carbon 12. Right, we have taken the carbon 12. So carbon 12 is not an atom, right? So it is an atom, but we call them as the isotope, right? So carbon 12 is an isotope of the carbon, right? Carbon has 3 isotopes. Carbon 12 is the, carbon 13 is there, and carbon 14 is there. These are the isotopes of the carbon. So we have studied about the isotopes, right? What are isotopes? Isotopes are, what is isotope? Isotopes are the atoms of the same element. Atoms of the same element with the same atomic number. Their atomic number will be same, but their mass number will be different. Right? Mass number will be different. Atomic number will be same. So isotopes are the atoms of the same element with the same atomic number but different mass number. So carbon 12 is an isotope of the carbon. Okay. Now we have seen in the that the mass of a hydrogen, we are saying that mass of the hydrogen is 1.67 into 10 raised to minus 24 gram, right? We have seen the mass of the oxygen also, right? Oxygen's mass, we have seen it as 26.56 into 10 raised to minus 24 gram, right? So these masses I have expressed in terms of gram, right? In terms of gram, we have expressed the mass in terms of the gram. Then we have told that carbon 12 atom, what is the mass of the carbon 12 atom that we are taking it as a standard? The mass of the carbon 12 atom, which is taking as the standard, is equal to, what is the mass of the carbon 12 atom, we have said that it is 12 AMU, right? 12 AMU. Then what is this AMU? I have no, here in the hydrogen and oxygen we have taken the mass in terms of gram, but the mass of carbon 12 is in terms of AMU, because when you look at the hydrogens and the oxygen mass, it is really small, right? It is 10 raised to power of minus 24. That means it is really small. So we need to convert the mass of the hydrogen and oxygen in terms of gram, to AMU, okay. So we will be getting the mass of these elements in terms of AMU. Okay, AMU. What is AMU? It is the atomic. We have already discussed this. Is it atomic mass unit? It is atomic mass unit, right? No. What is 1 AMU? What is 1 AMU? Now we need to convert the grams in terms of AMU, right? So 1 AMU is equal to 1 by 12th mass of carbon 12 atom. So 1 AMU means it is the 1 by 12th mass of carbon 12 atom. So what will it be? 1 by 12 into mass of carbon 12 is actually mass of the carbon 12 in terms of grams is 1.9927 into 10 raised to minus 23 grams. Okay, so this is a mass of carbon 12 in terms of grams. So 1 AMU will be equal to what will it be? 1 by 12 into 1.9927 into 10 raised to minus 23. So 1 AMU will get 1 AMU is equal to 1.66056 into 10 raised to minus 24 gram. So we got the value of 1 AMU. So 1 AMU is equal to 1.66056 into 10 raised to minus 24 gram. Okay, so that is the mass of the, no, 1 AMU is equal to 1.66056 into 10 raised to minus 24 gram. Now we can find out the mass of the other atoms in terms of AMU. Okay, so let us discuss the first one, hydrogen. So how can we find out the mass of the hydrogen? Means hydrogen, we know that hydrogen's mass is 1.67 into 10 raised to minus 24 gram. So we need to find out the mass of hydrogen in terms of AMU. So what we have to do is 1 AMU is equal to 1.66056 into 10 raised to minus 24 gram. So 1.67 into 10 raised to minus 24 gram. How can we convert into AMU? So hydrogen's mass in terms of AMU equal to 1.67 into. So how can we convert the hydrogen's mass in terms of AMU is equal to 1.67 into 10 raised to minus 24 gram divided by 1 AMU is equal to 1.66056 into 10 raised to minus 24, right? So this divided by 1.66056 into 10 raised to minus 24 gram. So what we will get is 1.0078 AMU. So we can rewrite it as 1.008 AMU. So we got the mass of the hydrogen in terms of AMU, that is 1.008 AMU. Okay. Likewise, we can find out the mass of oxygen also in terms of AMU. So you know that oxygen's mass. Okay, oxygen will be equal to, what is the mass of oxygen in terms of gram? It is 26.56 into 10 raised to minus 24 gram, that divided by, so 1 AMU is equal to 1.66056 into 10 raised to minus 24 gram. So when you divide these two together, you will get the answer as 15.994 AMU. Okay, so we can approximate it as a 16 AMU, right? So this is the what we are taking it for the calculation and all. So likewise you can find out the mass of all the elements in terms of AMU. So now we are using the mass of the element in comparing with that of the carbon 12 atoms. So we will be using the AMU as the unit for the atomic masses. But nowadays we have changed the atomic mass unit. This instead of AMU we are using a term known as U. What is U means? It is the unified mass. Unified mass. U is the unified mass. Nowadays we are using the term U to denote the unit of the atomic masses. Now the problem is that now using this equation we can find out the using this equation we can find out the atomic masses of several elements. All the elements atomic masses we can find out like this manner. But there are certain elements which are existing as the isotopes, right? So we have discussed about the isotopes before, right? So what will be the atomic masses in if that particular atom has isotopes? So that is what we are going to discuss now. So many of the naturally occurring elements is existing as more than one isotope. Okay, so when we take these isotopes, when we are finding out the atomic masses of these isotopes, we have to consider their relative abundance also. So relative abundance also we need to consider. What is this relative abundance? Is that suppose I am taking an example of the carbon itself. So carbon has carbon 12 isotope, carbon 13 is there, and carbon 14 is there. So these are the isotopes of the carbon. Okay, suppose I am taking 100 gram, or the 100 gram of carbon is there with me. So carbon 12, carbon 13 and carbon 14 will be there mixed in this particular 100 gram of the carbon, right? So each of these isotope, how much percent it is existing? Okay, how much percentage of carbon 12 is there in the 100 gram, or how much of carbon 13 is there in this 100 gram, or how much of carbon 14 is there in this 100 gram? That is what it is given by the relative abundance. Okay, so relative abundance is required when we are finding out the atomic masses of the isotopes. So suppose carbon 12's relative abundance is 98.892 percentage. Okay, that means if you are taking 100 gram of carbon, it has 98.892 percentage, it will be carbon 12 itself. Then 1.108 percentage it will be carbon 13, and 2 into 10 raised to minus 10 power percentage it will be carbon 14 also. Okay, then we need to find out the atomic mass of each isotope. So we need to consider the atomic mass of each isotope in terms of AMU, right? In terms of AMU. Carbon 12, we know that it is 12 AMU. We have seen it, right? Carbon 13's mass in terms of AMU is 13.00335. Carbon 14's atomic mass in terms of AMU is 14.00317. Okay, now we are going to find out the atomic mass of carbon 12 isotope. So when you are finding out the atomic masses of the carbon 12 atom, we need to consider the relative abundance and the atomic masses also. So the carbon as a whole, its atomic mass will be equal to relative abundance into its atomic mass. So you will get the answer as 98.892 into 12 divided by 100 plus, because it is in terms of percentage, right? Then 1.108 into 13.00335 divided by 100 plus 2 into 10 raised to minus 10 into 14.00317 divided by 100. So when you do the calculation, you will get the answer as, the final answer you will get as 12.01 1 AMU, or nowadays we are using the term unified mass U, right? Nowadays we are using the term U to denote the atomic masses unit. So we'll get the answer as 12.011. So this is how you need to do the relative atomic masses of the, in case of isotopes, relative abundance into atomic masses of each isotope added together, you will get the answer for the relative abundance of the relative atomic masses of the isotopes. Okay, so now you know how to find out the atomic masses, you know how to find out the, if it is an isotope, how to find out the atomic masses of the atoms which are having isotopes, and everything we have studied till now, right? Now using that, how we can find out the mass, molecular mass. It is a molecular mass, means mass of a molecule. How we can find it out? This is already you have discussed. Suppose I need to find out the atomic molecular mass of CH4, methane, right? So this is methane. I need to find out the molecular mass of CH4. So how you need to find out the molecular mass? So molecular mass is the sum of atomic masses of the elements present in a molecule, right? Present in a molecule. How you will find it out? You need to multiply the atomic masses of each element by the number of its atom, and you need to add it together, right? So let us do the CH4 carbon. What is the atomic mass of carbon? Carbon, it is, right? We have studied that it is 12.011 U, right? Into how many atoms of carbon are there? Yeah, only one, right? 1. Put the bracket. Plus atomic mass of hydrogen, what was it? It is 1.008 into how many atoms of hydrogen are there? 4. So you will get the answer as 16.043 unified mass. Okay, how can we find out the atomic masses of water? Okay, H2O, how will you find it out? Atomic mass of hydrogen, it is 1.008 into how many atoms of hydrogen are there? 2, right? 2 plus oxygen, right? Oxygen, atomic mass of oxygen is 16, right? So 16.00 into how many atoms of oxygen are there? Only 1. So you will get the answer as 18.02 U. So this is how you need to do the molecular masses. But in certain cases you can see that the molecules will be existing in the form of crystals. Right? In the form of crystals, they won't be occurring in terms of molecules. So some substances like NaCl, right? So NaCl means it won't be existing as a molecule. It will be existing as a crystal. It contains positive ions and the negative ions. It will be arranged in a three-dimensional manner. In that case, what you have to do is you have to calculate the formula unit mass. You have to calculate the formula unit mass. Again, the same techniques that we are using to find out the formula unit mass also. Okay, again, so we can do one calculation, NaCl, right? So we can take the example of the NaCl itself. Okay, same method you need to adopt. Okay, NaCl. So how you will find it out? NaCl. How can we find out the mass of formula unit mass of NaCl? Formula unit mass. In case of crystals, ionic compounds, we will be using the term formula unit mass. NaCl, the same manner itself. NaCl. Sodium, atomic mass of sodium is 23, right? 23 into how many atoms of sodium are there? Only 1, right? Plus Cl, what is the atomic mass of chlorine? It is 35.5 into how many atoms of chlorine are there? Only 1. So you will get, when you add it together, you will get the answer as 58.5 unified mass. So same manner how you have done the molecular mass. That's it.
Here is the list of atomic masses of the first 30 elements in the periodic table. Write down in your notebook and study it.
Now we can study about the mole concept. What is a mole? What is a mole? Mole you have studied in your lower grades, right? So mole is nothing but it is a number only. A number to indicate the number of particles. What is it? Whatever that number of particles are there. So that is indicated by the moles. Just like when we go to the shops and all, if we need 12 bangles. Suppose if you are going to buy 12 bangles, you will say that I need a dozen of bangles, right? A dozen indicates what? 12, right? A dozen indicates 12, right? Same thing if gross is a term that gross is a term that indicates how many particles. 144 items, right? In order to indicate 144 items, we will say that I need a gross of these things, right? The same manner, mole is also a number that used to indicate the number of particles. But a difference is that means mole is used to indicate the number of particles in the microscopic level only. We won't use moles to represent the number of bangles or the tables or the books or something. But mole we are using to indicate the number of microscopic particles like atoms, then molecules, right? Molecules, then electrons, ions, right? So these all etc, these all are the microscopic particles. So mole is a number to indicate the number of atoms, molecules, ions or the electrons present. Okay, just like 1 dozen means 12, a gross means 144. 1 mole means it has 6.022 into 10 raised to 23 particles. Okay, it's not just a simple number, but it's just a difference is that 1 mole is equal to, it is not a whole number, it is 6.022 into 10 raised to 23 particles, because microscopic particles mean is very small, so we need to represent a number which is very big, then only we can represent the number of microscopic particles. So 1 mole is equal to 6.022 into 10 raised to 23 particles in it. Now this number, that is 6.022 into 10 raised to 23 particles, we call it as the Avogadro number, right? We call it as the Avogadro number. We will represent it as Na, right? Avogadro number Na, right? So 6.022 into 10 raised to 23 is the Avogadro number, or we represent it as a Na. So from where do we get this number? 6.022 into 10 raised to 23 particle. Okay, so before that we can define a mole. How can we define a mole? A mole is the amount of substance that contains as many particles as there are atoms in. We are comparing it in exactly. Again we are taking the carbon 12 itself, exactly 12 gram of carbon 12 isotope. Okay, so what is a mole? A mole is the amount of substance that contains as many particles as there are atoms in exactly 12 gram of carbon 12 atom. That means 1 mole is equal to this much of particles, right? 6.022 into 10 raised to 23 particles. From where are we getting it? In 12 gram of carbon 12 isotope. In 12 gram of carbon 12 isotope, how many carbon atoms are there? That is what it is, 6.022 into 10 raised to 23 particles. So we are taking it as a standard because we have taken atomic masses, everything that we are now comparing using the carbon 12, right? So in 12 gram of carbon 12 isotope, how many carbon atoms are present. That is what we call it as a 6.022 into 10 raised to 23 particles. So we can just check the calculation of that. Okay, we can just check the calculation. Okay, now how do we got the 1 mole as the, how we got that the 1 mole of carbon 12 or the 12 gram of carbon 12 contains 6.022 into 10 raised to 23 carbon atoms are there. Okay, now we know that using the spectroscopy, different techniques are there. Now using spectroscopic techniques and all, we have found out the mass of one carbon atom. Mass of one carbon atom we found out. Mass of one carbon atom is 1.992648 into 10 raised to minus 23 grams. Okay, just to check the difference between gram and the AMU. Now I have marked the mass of one carbon atom in terms of gram. Okay, this I found out using the spectroscopic methods and all. Okay, now we have found out that one mass of the carbon atom in AMU, right? In AMU, you know that, right? So we can say that 1 mole carbon atom, 1 mole carbon atom, 1 mole carbon atom. We have taken how much of carbon atom as the standard one? We have taken 12 gram of the carbon atom, right? So 1 mole carbon atom means it is the 12 gram itself, right? So 1 mole carbon atom is the 12 gram. So we have 1 mole is, we have found out that number 6.02 Avogadro number, right? So how we have found out? We have found out that in 12 gram of carbon 12 in 12 gram of carbon 12 atom of the carbon, how many carbon atoms are there, right? So now 1 mole carbon atom is equal to 12 gram. So number of carbon atom, how can we find out the number of carbon atom in 1 mole? How can we find it out? It is equal to mass of one carbon atom is this much, 1 mole carbon atom is 12 gram. So number of carbon atom in 1 mole is, how will you find out? 12 gram divided by 1.992648 into 10 raised to minus 23 gram. So what will you get it as? The 6.022 into 10 raised to 23 atoms. Okay, so that we have found that number of carbon atom in 12 gram carbon 12 isotope is 6.022 into 10 raised to 23 atoms. Now we got that in 12 gram of carbon 12 isotope 6.022 into 10 raised to 23 atoms are present. That is what we found out, that 1 mole is equal to, now we have related it, 1 mole, we kept this as the constant. 1 mole is equal to 6.022 into 10 raised to 23 atoms. So whatever that we have taken, I have taken 1 mole of hydrogen atom. Okay, we need to specify which particle it is. 1 mole of hydrogen atom means I have 1 mole of hydrogen atom with me, means I have 6.022 into 10 raised to 23 hydrogen atoms are there with me, right? I have 1 mole of water molecule with me. H2O molecule is there with me. What does that mean? I have 1 mole of H2O molecule means I have 6.022 into 10 raised to 23 H2O molecules are there with me. Okay, so likewise we can find out the number of moles or the number of particles present in it, right? So now how can we find out the mass of different molecules? Suppose I have taken okay, now we need to find out the moles, number of moles. How can we find out the number of moles? Number of moles is equal to given mass. Given mass means whatever that mass of the particles divided by its molar mass. Okay, so number of moles is equal to given mass by molar mass. What is this molar mass? Molar mass is the mass of 1 mole of a substance. In grams. in grams is known as the molar mass. Okay, so molar mass is a mass of 1 mole of a substance in grams. Okay, now what is the molar mass? So we have studied it, right? Molar mass also we know that. What is the molar mass of carbon? Carbon, it is 12, right? 12 in grams, right? 12 gram per mole. So in 1 mole 12 gram is present, right? Now what is the molar mass of chlorine? 35.5 gram per mole. That means if you are taking 1 mole of chlorine atoms, it contains 35.5 gram present in it. It is standard, right? So we have studied that also. So at the end of this video, I'll be giving you the most common elements, molar masses also. Okay, now we can use the formula number of moles is equal to given mass by molar mass. You will get the number of moles present in it. Now I need to find out the number of particles present in it. Okay, how will you find out the number of particles? Number of particles is equal to number of moles into Avogadro number. Number of particles is equal to number of moles into Avogadro number. Using these two equations, we can do the a lot of calculations also. Numerical problems we can solve using these two formulas, right? So number of moles is equal to given mass by molar mass. Then number of particles is equal to number of moles into Avogadro number. So can we do the numericals using this formula, right? So I'll be writing the first question over here. Okay, so my first question is, okay, calculate the number of moles in 9.8 gram of H2SO4. So my question is, calculate the number of moles in 9.8 gram of H2SO4. So our question is to find out the number of moles, right? So number of moles we are representing using the small letter n. N is equal to given mass by molar mass. What is the given mass? Means how much of H2SO4 is there with us? It has 9.8 gram, right? 9.8 gram divided by molar mass of the H2SO4 we need to calculate. Okay, so molar mass of H2SO4, how will you calculate? H2SO4, right? What is the atomic mass of hydrogen? It is 1 into how many atoms? 2 plus, okay, now sulfur, what is the atomic mass of sulfur? It is 32 into 1 plus oxygen, it is 16 into 4. So what you will get as answer? 98 gram. Okay, so 9.8 gram divided by 98 gram. So you will get the answer as 0.1 mole. So you got the answer as the 0.1 mole. Okay, now let us do the next question. Hope that question is clear to you. So we can do the next question. Second question is, what is the mass in grams in 2.5 moles of slaked lime? Okay, so this is the question. What is the mass in grams in 2.5 mole of slaked lime? So what you need to write is slaked lime. What is the formula of slaked lime? What is slaked lime? CaOH12. Okay, now we need to write the whichever that data which is given over here. It is given 2.5 mole, right? So number of moles, small letter n is equal to 2.5 moles. So what do you need to find out? You need to find out the mass. Okay, number of moles is given, right? We need to find out the mass also. What is the formula? Number of moles is equal to given mass divided by molar mass. What is given mass? that you need to find it out. So given mass is equal to number of moles into molar mass. Now what is in a molar mass? Calcium. Find it out. Calcium, it is 40, right? Oxygen, find out the oxygen, how many atoms of oxygen are there? 2, right? So 16 into 2. Then hydrogen, how many? 2 atoms are there? 2 into 1. So we'll get the CaOH twice as the 74. Okay, so do it. Number of moles is equal to 2.5 into molar mass is 74, right? So what is the answer? 185 gram. 185 gram. Hope you got the answer. Now we can do some more questions, right? We can do some more questions also. That questions I will be posting in your group, so try to do the numericals using these two formulas. Hope you got that.